We have a couple people coming in the back, but let's get started. I have a lot of slides today, so we are going to try to use the time that we have. So, good morning. Today I want to talk about, you guessed it, search. And before we talk about search in Drupal, this is the Drupal event after all, I would like to take a step kind of away from Drupal and look at the wider picture. What is the expectation of a user nowadays when it comes to search and the user experience that a user will have when dealing with a search interface? So a couple examples. One that you probably know, Wikipedia. When you search on Wikipedia, there's an autocomplete that comes here that gives you suggestions of articles. Even if you mistype something, if you type Helsinki instead of Helsinki, it will find the right place with the right article, and you just jump straight through it. You also have the possibility to do an actual search and still search through all the articles for specific keywords, but you have this shortcut that really lets you jump straight to the right article. So you really have both options. If you look at another example that you probably know, Amazon. When you search for something on Amazon, you also get autocomplete suggestions, and you get these that are combined here with specific facets that are already combined with the suggestion. So you're saying, I'm searching for books about Helsinki. So you're already jumping deeper into the search parameterization, but the suggestions that you get here are all search suggestions. So it's not like the case of Wikipedia where you just jump straight to an article, or in this case a product. You jump to a search. So it's a search suggestion, it's not a direct result. Another example, Spotify. Here on Spotify, when you search for something, you actually get a lot of different suggestions. You can search for a song, for an artist, for an album, and actually most of the suggestions or most of the things that you could be looking for will be showing up in this autocomplete. There is a search result page, but practically you will never need it. And actually, if the system works well, you will never see it, because this will never be the option that you choose. On GitHub, you also have a nice discrete search interface. And what's nice here is that by default, you are searching not the entirety of GitHub, you're searching within a specific repository. So it is a search that works by default in always a subset of the entirety. If you search on Stack Overflow, here you have a very simple search interface as well. Here you typically search for more complex phrases, so you're not necessarily entering keywords. An autocomplete doesn't make sense in this case, but you see that the ranking actually is combined of many different parameters. You see the second result here has less votes and less answers than the third one, but somehow it is more relevant. And so we see that relevance is really a combination of many different factors. And we have a lot of results here. And it is what the search is doing, it's not necessarily filtering out results. It's really what's much more important is sorting them so that you get the relevant ones first. And then the more you go through the paging, the less and less relevant it becomes. So the sorting is much, much more important than actually filtering out things that are not relevant. What do we learn from these examples? Well, first of all, there is no one-size-fits-all approach when it comes to search. You need to make sure that the search experience really matches the data that you have. It matches your business logic. And this really needs to happen at every layer of the technological stack. Starting from the front end, the user interface needs to be nice and responsive. This is why we have a lot of autocompletes, because they really guide you without having to reload the page. So it is really an interaction. And so you have this adaptation, this fittingness to your business logic that happens at the UI level. It also happens at the proxy level, the middleware, where you actually create your queries, where you define what kind of data you want to get out of the search index, and then finally it also has to deal with the search index, the storage. How do you store the data so that you can actually retrieve it correctly? So that's one of the learnings that we can see from these various examples. Another thing that all these examples have in common, all of them are built with Elasticsearch, with one exception, and that one exception is Amazon. Actually, I don't know that they're not using Elasticsearch, but I don't know for sure. And the reason I'm pointing that out is because a lot of people, when they hear about Elasticsearch for the first time, they think Elastic something, it must be an Amazon service. And no, that's not the case. Elasticsearch is an open source project, has nothing to do with Amazon. So let's get back to Drupal. How does search look like in Drupal? Well, it looks like this. And actually, that's very nice. That's, you know, you get a nice icon. It has all the right metadata markers and all of that. But it doesn't look really that different from the search in Drupal 4.7. It's also a text box search, nothing more. And in Drupal 4.7, why do I mention that particular release? Because, well, if you look at the changelog, that's actually when most of the changes were done to Drupal core search. And since then, there's been a couple of improvements, but like the system really hasn't changed much since Drupal 4.7. To put that into context, at the time, the iPhone and Android devices did not exist. All of these examples that I showed you before, the companies didn't even exist yet either. And at the time, MySpace was still cool. So if search is important to your project, do not use the Drupal core search module. And if search is not that important to your project, well, don't use it either. But Drupal core search is not the only option that we have in Drupal. Actually, shortly after release of Drupal 4.7, there's one guy who tried to push an idea forward, this guy, Robert Douglas, and he tried to push the idea of using Apache Solr to handle search outside of Drupal. So it's an external system that just deals with searches, and Drupal integrates with that. And he did a great job at evangelizing this idea because, well, after all, Apache Solr, it is fast. It gives you great text analysis, so stemming, understanding of language, all of that, stop words, all the things that Drupal does not have. And also, it gives you facets. And yeah, these are all great things, but in the Drupal community, there's some kind of, this idea that advanced search means facets kind of stuck a little bit too much. And facets are great, but now they're kind of like, it's an expectation that if you have a search case where facet might be relevant, then you will have facets. But we need to forget this idea that really good search means facets. This is, this is nice, but this is not the end of the story. There's also another project that is kind of the standard nowadays for search in Drupal. This is the Search API. It takes the idea of Apache Solr and kind of makes it more generic so that you can use it with any kind of search backend. You can use it with a database backend, you can use it with Apache Solr, you can use it with Elasticsearch, and it abstracts away the differences between these systems and lets you build search-enabled things with views, so you have something that's really that feels really well known for Drupal developers. But here again, we have facets, and it kind of stops there. So if you want to do anything that's specific to the kind of things that you have, it's specific to the database backend, the search backend that you chose, then you still have to kind of bypass all this system. And this is why I would like to talk to you about Elasticsearch. Elasticsearch, as mentioned, it's an open source project, and I first came into contact with it about, I think, 3 or 4 years ago on a project for which we were using Node.js, so not Drupal. And about halfway through the project, we realized that we were having major issues with Apache Solr, and we decided to switch over to Elasticsearch, or to at least try it. And actually, the switch happened in something like half a day of work. And we realized, hey, this is actually really, really nice. And yeah, it was fun. And so we liked it. And if you want to look more into why Elasticsearch is great, there's plenty of information online, and there's really all bunch of arguments. Just look them up. I think there's plenty of good reference, good resources out there. So I'm not going to go into these. But I think for me and for what I see, the kind of issues that we have in Drupal projects with search, I think there is one point that really makes a difference with Elasticsearch, is that it has a really nice API to work with. It's something that lets you do the things that you want to do. It's just very nice, and it's a fully RESTful API, so it's technology that we are familiar with, much more than Solr, for example. So posts and GET requests, structured JSON, this is just our day-to-day work, and so it's very easy to just get started with this API. And there are also very good libraries in pretty much all languages, PHP, JavaScript, Ruby, if that's what you're into, and pretty much all the other languages. So yeah, very nice. And Elasticsearch kind of like, it went on the side for us for a little bit. And then last year, it was the fall, we had a customer that came to us and asked us to build an intranet. It had to be very simple, very slick, and one of the features that they wanted is a very powerful search, very easy search, and it just had to work. And that's one of the important things that we need to remember, is that an advanced search does not necessarily mean something complicated. An advanced search means that it's something that actually lets you, it has all the tweak to let you as a user just get the stuff that you want. And what we've seen is that it's actually possible to build things that are advanced, but they are simple, both for the user and for the developers. I'm not allowed to show you the intranet that we built for the customers, but we like the product so much that we actually reuse that intranet for ourselves. And actually Mario and Teemu will be giving a presentation about this specific project after lunch break. But here's what the search part looks like. So if you're anywhere on the site, you start typing directly and the search comes up automatically. If you want, you can also click on the search button directly to be explicit. It should start. Yeah, so you start typing and you see you have results, and then if you pick one of the direct results, you just jump directly to the right page. The front end is built with Angular, so it's all very smooth. And you also have the traditional search page if the autocomplete does not give you exactly what you're looking for. So how did we build this? Well, first, get started with installing Elasticsearch. There's an apt-get, an apt repository. So it just like a couple lines of a couple commands, just do that. You can also install a binary directly. And so that gets Elasticsearch running on your system, and then you can install the PHP library for it, and you can just do that with Composer. I think everybody here is using Composer, right? Yes? Okay, so now we have Elasticsearch and the library installed on our system. It's time to get data into that search index. How do you do that? Well, indexing. We have entities in our Drupal system, and we can use the good old hook entity updates. So whenever an entity gets inserted or updated, what we're going to do is that we're going to get our client. This is using the PHP library, and we say that we're going to load it from a specific host. Actually, the only configuration that you need here is what host you want to talk to for Elasticsearch. And then here, what we're doing is that we're telling our client that we want to index something. It's going to be in an index called content with the type article. The type is to the index kind of like what a table is to a database in MySQL terms. You can also specify an ID, and for the body, you just send whatever structure you have. And that's one of the beauties about Elasticsearch, is that by default, it just takes whatever you give it. So you get started very quickly, you are productive very quickly. There's one issue though with the code as it is. Well, actually there's a couple issues. We should be putting this into services, and we should be doing error handling, exception handling. So these are things that we're doing in the code that we actually use, but this is actually the minimum to actually get started. But the problem with this is that Drupal, by default, when you send it an entity, it serializes things like that. And that's not really nice. I mean, it doesn't really make sense that the ID is going to be an array with an object inside of it with a value attribute, and that value attribute is a string with a number in it. That's not what you want. That's not the data that you want to have in your front-end application, and this is also not the data that you want to have in your search index. So what we are doing is we are using Drupal's serializer module and serializer API to just, when an entity gets saved, we serialize it with a custom serializer, and then this is the data that we put in Elasticsearch. So the same way that you would serialize data in a specific format when you are creating REST services, you also serialize it before putting it in Elasticsearch. And this is something that's really important. Although you can't just send things straight, it really makes sense to make sure that the data that you put in your search index matches your business logic, and it doesn't need to be structured exactly like a Drupal entity. So what you get out of that is an object like that, because that's what we decided to have. If you want to look into this, just look up the normalization part of the Drupal 8 serialization API. I'm not going to go into detail now. So this determines how we structure the data before sending it to Elasticsearch. But we can also tell Elasticsearch specifically about what schema it should have. And by default, again, when we send something and it indexes it automatically, it creates a schema for you. But you can also override or like really explicitly define the schema. This is also just a GET request, or actually a PUT request, where you just create in the indices API, you put a mapping for an index called content, type called article, which we already had before. And here we define the properties that we have. We have a label and content. For example, for the content, we say, yeah, it's a string, which is the default already. But we specify that it's going to be analyzed as English text, so that we have proper stemming, proper escaping of apostrophes, things like that. For the label, we are also defining this as a string, but we define a few other things, like how it should be parsed in terms of auto-completion. This is a little bit more advanced, but you can really get very finely granular into how you want to index the data. You can also take one piece of data, like the label here, and have one version that's just a label, and then you can have multiple ways of analyzing that data at the same time. This is also very, very nice API. It's quite easy to understand. There's a lot of possible options, and it's worth looking them up, but the documentation is also very good. And by the way, this is the kind of code that you would run when the module gets installed, for example, in hook install, something like that. So this is how you define the schema once before indexing data. Then the last step is, of course, we need to search. We need to query the data. And for this suggestions, so what you see when you're typing in our user interface, the data comes from a query that looks something like this. where we are actually searching not only on the content index, but also on the user index, so that the auto-completion works across all kinds of data. And so you just specify multiple indices, and then Elasticsearch will just combine all the results for you. Here in the query, we are using a multi-match query because we want to search on multiple fields, and we are searching for that thing that the user has input. Of course, you want to escape that to make sure that there's no cross-site scripting stuff. And on the field that you want to look for, we're searching on the label and also on the label autocomplete. And what you see here, this little hat and 5, this actually means that this is going to be 5 times more relevant than this. And here for the autocomplete, we are taking parts of the words. And then for the label, we are taking entire words. And so this means that it's going to match both something that's a partial match and a complete match. But if there is a complete match, then this is going to be a lot more relevant. So this is some fine tweaks to the relevance that really make a whole difference. For fuzziness, we're specifying auto. This means that Elasticsearch will automatically determine how many characters can be wrong when you find a match. And so the longer the word, the more mistypes are allowed. And also one small detail that actually makes a big difference, the prefix length. So when we have fuzzy search, by default it's just going to allow mistakes or mistypes anywhere in the word. And when you specify a prefix, it's telling, well, for in this case the first character, we're not going to allow like typing errors on this. And it turns out that when you're typing, if you mistype something, it's usually not on the first letter. And also what this gives us is it makes it possible to avoid things, suggestions that look out of place. And this is something that's really important. You want to give suggestions to your users that the user can understand why these things are there. So this is one of the major differences between creating the search result page and then the quick and fast results that you have in the auto-suggestion. In the auto-suggestion, you want to suggest things that the user really understands. And most of the time, it is to answer questions that the user knows the answer to. So when I'm searching for the name of a colleague, I know who I'm looking for, and I want to select that directly. When I'm falling back to the search page, then it turned out that I don't know exactly what I'm looking for, or I don't know if it's there, and I want to see, well, is there anything to this, matching to this topic? So making sure that you have, in your suggestion, that you have something that the user understands why it's there is really critical. And also finally, we are specifying what part of the source we want to get. So Elasticsearch will return the objects with exactly the same structure that you put them in, but you don't necessarily need all the information. For example, for articles, we don't need the entire body when we are creating our suggestion results. So in this case, we just need these fields, and that's the only thing that Elasticsearch will return. So this is the result, and yeah, it worked quite well. The customer was very happy. We had a very good time building the project, and we were actually quite convinced by the thing that we built, and we decided to use it on another project. This is a catalog, the online catalog for Avery. If you don't know Avery, they are the ones who make like print-at-home business cards, among others. They're like, you have, I'm pretty sure most of you have bought office supplies at some point in your life from that company. You probably don't know the brand though. But one of the typical use cases that they have is that, well, a customer buys a product in the store, and then on the packaging there's a code that says, if you want to download the template, the Word template to create your business cards, just type that code into our website. So this is what we are making possible here. We are typing product codes. And the thing is that product codes need to be parsed differently from just regular text, because if there's a dash in the middle of a product code, then maybe sometimes you you don't want to treat that as two separate words. So you need to really understand how is the content that I have being analyzed. So that's one part of the challenge. And then there's like within the same search interface, there is a different kind of search, and I think it's looping, or no, it's not. Okay, so we'll just go through this again. Yeah, so here you see again, I'm typing for product code, and it's auto-completing on that, loading the result. And the second part, which is quite interesting, I'm searching and getting auto-completions for product properties. So in this case, I'm looking for size A4, and it's going to be white, and I want stickers. And so I have suggestions that are actually dependent on the projects that are available. So for example, if stickers were not available in white, then I would not see white as a suggestion here. So how do you do that? So this is slightly different. What we're doing here, the query part is the same as before. We're limiting the products to things that match, and then we are looking for aggregation. And aggregation is kind of a generic word for facets, or the kind of data that you would use for facets. And we create an aggregation called suggested terms, and it's of type terms. So it's going to return individual words or terms. We are doing this on the field suggestions. The field suggestion is a place where we aggregate all the things that could be relevant about the product. So the size, the material, various properties, is it waterproof or not, things like that. And so we put all this data in here, and then we actually exclude part of the facets, and we actually do this by only including the ones that match what we typed in. And this gives us faceted search within the autocomplete. And it's something that just feels very natural to user. And here we're only returning seven values. And then you get a structured JSON, which in PHP is a structured array from the result. And then under aggregations, you have your suggested terms using the same ID that you used before. And then in the bucket, for each bucket, you take the value of that and put it in your response. And there you have a very, very fast autocomplete that returns within a couple of milliseconds. And actually, the Drupal part is much, much slower than the querying in Elasticsearch. And so the customer was really happy with this, and it took a few iterations to figure out exactly what data we wanted to have in there, because this is something that we realized that a lot of the time customers don't know what it takes to, what is search really? And even designers, when they create a search interface, they say, we're going to have an autocomplete, and they show you what the autocomplete will look like. But until you have real data in there, you don't know if it's going to work like that. So this is something that it really takes a lot of, trial and error and seeing what works and what doesn't. And it is very much a data-driven approach more than just defining up front what kind of data you're going to have, because you don't know what data you're going to have. We also used this similar approach for another project, which is a tool for real estate professionals. And what we're doing here is that, we are providing saved searches so that people using the system can say, I'm looking for a house to buy in this neighborhood, and it should cost more than €500,000, and it should cost less than €500,000, and it should have more than 50 square meters, and this and this. So very nice structured search. And what we're using for the notifications based on the saved searches is we are using what is called a percolator Percolator is kind of coffee maker that used to be very popular. It's not so popular anymore. I actually just learned this while preparing the presentation. But yeah, it's actually the only reason why we should care about this is that this is where the name comes from, but this is actually an API, a mechanism provided by Elasticsearch that makes it possible to index not only the documents that you want to put in your search index, but also index the searches. And then when you put a new document in your search index, you can run a query against the percolator, and we tell you, these are all the saved searches for which the document which you just submitted is a match. And the advantage with this is that it scales really, really well. So you can have millions of saved searches and millions of documents, and it still scales without needing to run the searches over and over again to see if there are any new matches. So this scales really well, and it's also very nice to use at low volumes. So as you can guess, well, after doing a couple of projects with this approach, we started wondering, well, is there a way that we can make this more optimal? And really, it's not that much work, that much code for each project to set this up. But there are a few things that are always the same, kind of the mechanisms for how you index the content, the mechanisms for what drush commands that set up the index and delete the index and re-index things while during development. And that's the reason why we created this module called Elasticsearch Helper. And it's not a module for site builders. This is a module for developers that actually make your life easier. It does not provide any kind of user interface. It provides APIs. And I've been spreading this idea and this process internally with a couple of people, also at a couple of Drupal events now. And people have started using it and have been giving very good feedback, also giving back some improvements. So it turns out to be quite well, to be very well received. It's not very popular just because it's not targeted at site builders. It has a pretty narrow audience, but the people who have been using it have been very happy with it. An example is colleagues from Belgium, a project in which I was really not involved. They used this module to create a search system for student housing in Brussels. And what they're using here, you can see they're using Elasticsearch geographical search capabilities, which also works just out of the box. And what they're using here for the apartments as well is that they're using parent-child relationships to manage, for example, student dorms that have 50 apartments. And they're all the same, and they all cost the same, and they're all the same size. So it doesn't make sense to have 50 times the same results in there. So you would have only the result once, but you would still know if there's something available and so on. So this is something that is generally missing from the search world, this kind of parent-child relationship, because this is quite a tricky challenge, and Elasticsearch has very good tools to solve this. Another example that I can't show you at the moment because the project is not launched yet, but I thought that what my colleague did was very cool. It's a project where they're using Elasticsearch for indexing and for like retrieving what should the search results be and how should they be sorted. But then they actually wanted to use kind of a traditional process for just displaying results, and they're using views. And so they wrote a small plugin that actually takes the search results from Elasticsearch and just passes them on to Vue and say, just render these as entities. And it works really well. So this approach that I'm showing is not strictly limited to when you have fancy UIs with Angular and React. It also works with more traditional site building methods. There's one last project that I would like to show you. This is a project that we're working on at the moment in Germany for a company called Sportcheck. This is like a very large sports retailer, and they have 500,000 products in their e-commerce system, which is not built with Drupal. But what we're building is we are building a content management system for the various metadata that they have in that e-commerce system. So yeah, very meta, but a very cool project. And here we're dealing with a lot of data. And at first we were getting the data into Drupal because it needs to be edited. There's workflows that are involved. But we realized that for a lot of these processes where we are doing batch processing over a lot of data, Drupal was not exactly adapted. And what we did now is that we are putting the data that we get from this external system into Elasticsearch, and then we use these search indices not to create searches, but to create different listings and different data preparations that we need. And it works really well. So it works well for listings, and it also works well for various visualizations that really let them interact with the data that they have. For example, a tree of the product categories that they have. So in this tree, they have something like 6,000 product categories. And previously, when we were loading that data from Drupal, after a good amount of optimization, it was taking 3 to 4 seconds. And it was okay, but it was kind of slow. And then when we switched to Elasticsearch, just changing how we fetch the data, it went from 3 to 4 seconds to 200 milliseconds. Just fetching the data part. So that's really like 10 times faster, which, it's cool. But actually for a page like this, if you have to wait 3 to 4 seconds, that's not too bad. But where we see the real benefits is for some of the listing pages that we had, where we were doing batch processing, for example, we had a case where we had 32,000 items that we needed to export as CSV file. And we realized that, well, with Entity API, it's just so slow that it's not possible. Or it would take some really complex queuing system that just adds stuff to a file. And we realized that we wouldn't be able to use any of the standard plugins for views like CSV export. And switching to Elasticsearch, it meant things went faster. And it's not only about going faster, but it's also about going so much faster that it makes things possible that would otherwise not be possible. And this is also using the Elasticsearch helper. And then we see that as previously we're using entities and putting them through a serializer and then in our search index, now we're taking data from elsewhere using some serializer and putting them in Elasticsearch. And sometimes when the data that you get from elsewhere is nicely structured, the serializer doesn't really need to do anything. And what's cool is that now we have all this data in Elasticsearch, and we can use tools like Kibana. And Kibana is a data visualization tool that's used for all kinds of things that just connects directly to Elasticsearch. Very nice, very easy to use, lets you create visualization, lets you create dashboards, and we are putting this in the hands of our customer. So that even if, we could do this for any project that uses Elasticsearch, this is a very nice way for customers to understand what kind of content they have, what kind of data they have, and really be able to dig into the data and explore the data they have and really learn new insights from the data that they have. There's one last point that I would like to mention, that at the moment, we and pretty much all Drupal agencies, we build a website. We might say, yes, we build web applications, and actually, in the end of the day, it's all things that get displayed in a browser. And I think that what's interesting about search is that, yes, there are some very cool overlaps with websites, and there are very nice integrations, but there's a whole world behind that that is also very exciting, especially when we're thinking of conversational interfaces like Amazon Echo or the Facebook chatbot. These kind of interfaces that happen outside of our browser. We see that our websites are, well, there are some interfaces there, but they kind of become obsolete. While search, on the other hand, is still a critical component of all of that. And so if we learn to build searches not in terms of building websites that have search box, but in terms of understanding what search really means, then it means that we will be able to build relevant interfaces even when websites are not relevant anymore. So in summary, search is important. And it's important to take care of the details because it's the details that matter. It's the details that make the difference between a search that people won't use and a search that people will use without even realizing it. And to do this, you need to make sure that you are not building things that are complicated. You can build advanced stuff, but it should remain simple, both in terms of the architecture of your system and in terms of the interfaces that you provide to your users. And Elasticsearch provides a very expressive API that lets you do exactly that. And personally, I think that Search API limits you in terms of what possibilities you have, but it is possible to use Elasticsearch with Search API. So if you want to try that route, that works too for some use cases, but I would encourage you to also look at some other alternatives. And finally, and I think this is the most important point, Elasticsearch is really fun to work with. And this is the feedback that I've heard from all the people that I've been talking to about the projects where they use Elasticsearch. They say, this is really fun. I feel good about working with this. And the customers say the same thing. They are happy. And I think that, yeah, Elasticsearch lets us generate a lot of value in terms of money, because our clients are happy and they make money and they pay us money. This is great. But also in terms of happiness, because we are working with stuff that's fun and then we go home happy at the end of the day. So this is something that I would definitely recommend you to look into. Do you have any questions? Yes?
I make notes.
Let's wait for the microphone so this is recorded as well.
Yeah, I'm Kees from Exovet. And I wondered if you were willing to elaborate on what problems you had with Solar in the first place when doing the internet. Do you have any concrete examples where what went wrong?
For the intranet project, we didn't use Solar. That was on a previous project that was actually doing something that was like a Node.js application, as I mentioned, that was integrated with Drupal. Something that was quite complex setup, and we needed to have some advanced changes to the schema. And the problem is that the schema in Solar is stored in an XML files on the server. And what we realized is that we had really deadlocks in deployment that we needed, like if we didn't change the schema exactly at the same time, then we would have queries that returned fatal errors. And so it meant that we had to do deployments across multiple services really concurrently, and that we needed to shut things down, which was really not fitting for the project. And with Elasticsearch, all the schema changes actually happen through the API. Just like with MySQL, if you need a new table, then you have a SQL query that will create that table. And this makes it possible to have really a much easier deployment system. So that was really the one problem that we had. And then we realized that there's plenty of other reasons. That, for example, scalability. If you try to scale Solar to like a redundant system, you need things like Zookeeper that really adds a lot of complexity to your system. Whereas with Elasticsearch, you can say, well, I have a node here, I have another one here, just talk to each other, and it just works, which is really fantastic.
Thank you. I have another, if you doesn't mind. You showed the office supplies example when there was a string of data just injected into the variable. And I was wondering if there have been any prevention mechanisms for like, you could probably cause mayhem in the index if you were to be like mean,
yes.
A mean user.
So I simplified these examples quite a bit. So of course, for example, when we're treating regular expressions, you need to make sure that you escape those properly. So there's just like any endpoint that you create, you make sure that you sanitize the data before letting your user interact with it. So yes, always make sure to put proper checks in place.
All right, thank you.
I was wondering about, you said something about parent-children relationship.
Yeah.
So what were you referring, for example, if you have a node, and then you have, for example, entity reference to some other data? Was that, do you mean this kind of thing?
Yeah, so the example that we had is that we had like a landlord kind of entity, and then apartments that could potentially belong to a landlord. And so we wanted to only show things once per landlord. And so there's a lot of possibilities that you have there. And so you can actually query the landlord. So you can say, show me all the landlords that have available apartments, or show me all apartments for which the landlord is of this type. And so this makes it possible to have relationships which are otherwise not possible, because Elasticsearch, like pretty much all search systems, there are NoSQL storage systems which don't handle relationships. And this is, it's not as powerful. It doesn't let you freely define relationships, but it makes it possible to have this kind of parent-child relationship that solves these kinds of problems.
So how does it work? So do you need to, for example, if you get a result from Elasticsearch, it has some reference to another object, or how does it work? Can the Elasticsearch build the relationship in the result?
Yeah, so you actually need to have the relationship when you index it, so that the parent and the child end up in the same place, because Elasticsearch is a distributed system, or it can be distributed, and so you need to make sure that they are in the same shard on the same server. So you need to specify that relationship when you index the data, and then when you retrieve the data, there are some specific filters that you can use, a parent filter or parent query, and the opposite, a child query. I like to say, well, I want all these, and for which the parent has this and this.
So you have to, if you want to manage, for example, if you delete children, then you have to make sure that the parent object in the Elasticsearch index is also updated, right?
Yes, but this is actually an approach. When you have this kind of complex relationship, it's nice to handle the integrity of your data, for example, in Drupal. So that this is where you have all the structured logic, and where you handle, like, if the child is deleted, then also delete the parent if for example, that was the last child of that parent. And then just use hook entity update, for example, so that whenever that structure gets updated, then you also update the search index.
Thank you.